All right, so now we're moving on to example 4 of finding domains and ranges of functions using graphs. So here we have a graph that looks like a red arc that goes from -2 to 2 and then picks up at 2 and goes to 5 on the x-axis. So this is all part of one graph. I'm not going to go through the explanation of determining whether or not this is indeed a function. It is a function. Each x value goes to exactly one y value at most. It is not defined everywhere, so if I try to plug in -5, there's no graph, or there's no y value that corresponds to x is equal to -5. So it's not defined everywhere, but where it is defined, there's only one y value that comes out. Okay? So we need to find the domain of this guy. Domain of f. Okay, so we're going to use the same scanning methodology that I used in the last example. So I'm scanning from left to right, starting as far to the left as I possibly can, i.e. -infinity, and asking myself, am I touching the graph? Am I touching the graph? No, no, no. Where do I start touching the graph? I start touching the graph at -2, okay? And there's a closed dot there, so that means if I plug in x is equal to -2, I get a y value of 1. So it is defined there. So we start our domain at -2. Okay, continuing to scan along. I'm still touching the graph, still touching the graph. Where do I stop? Oh, it looks like I might stop here at x is equal to 2. It stops on this part of the graph. However, it picks up down here where it left off. So there is an open dot here, but down here, if I were to plug in x is equal to 2, I would not get 1 because that's open. But it's closed down here, so x is equal to 2 goes to -3. Okay, y is equal to -3. 2 gets mapped to -3. Okay, so we picked up where we left off. There is no jump in the domain here. So I can continue scanning, still touching the graph, still touching the graph, still touching the graph. Even though I jump here, I'm still touching the graph. And then continuing along, I'm still touching the graph. And then I stop at x is equal to 5. The graph, so if I kept scanning this way, I'll never touch the graph again. So I stopped at 5. So I will write that. And do we want an open brace or a closed brace? That is, do we want a square bracket or a round bracket? We want a square bracket because it's a closed point here. So if the closed dot, use a square bracket. And that's the domain. I can continue scanning from 5 onward and I'll never touch the graph again. So these are the only x values I could plug into my function and get something out for. Okay, so now let's look at the range. Range is the set of all possible y values that come out of our function. So we start scanning at the bottom, basically at -infinity. Scan up, am I touching the graph? No, no, no. When do I start touching the graph? Right here at y is equal to -3. And it's a closed dot, so I can write this as a square bracket, -3. Okay, let's see where I stop touching the graph. Okay, I'm still touching, still touching, still touching. Even at this point where there's a jump, I'm still touching it. So I'm still touching it, still touching it, still touching it. When do I stop touching it? Right here at y is equal to 4. And then from then on, I no longer touch the graph. So I'm stuck at 4. And do I include 4? Yes, because if I plug in 0, I get exactly y is equal to 4. All right, so I stop at 4. And I use a square bracket because the graph actually is technically a closed point there. And I don't continue on, I can't put a union, anything else, because I stop there and I never start again. All right, so that is the range of this function here. So we found the domain, we found the range, and we're done. All right, so in the next example, we'll do something similar, but it'll be broken up into 3 separate pieces. So I hope to see you in that video.